friends, welcome to Nabla Online Maths. Today, we are going to learn how to find the highest common factor or the greatest common factor of numbers. And I have one example on the board for us to solve. The example says, find the HCF or GCF of 12, 20, and 36. HCF means highest common factor. GCF means greatest common factor, and they all have the same meaning. So to find the highest common factor or the greatest common factor of 12, 20, and 36, I'm going to teach you three different ways of doing that, or if you like, three methods. So let's go through the methods. Method 1, that is the first method. Take each of these numbers and find their factors and put them in curly brackets. That's first step for the method 1. So I'll take 12. Factors of 12 are 1, 2, 3, 4, 6, and 12 itself. Then I'll take 20 and find its factors. Factors of 20. I'll have 1, 2, 4, 5, 10, and 20 itself. Then I'll take 36 and find its factors. Factors of 36, 1, 2, 3, 4, 6, 9, 12, 18, and 36 itself. These are the factors of 36. Then, next step, you look through all these three sets and pick out numbers or a number that appears through all of this. So you can see that the intersection of this, 1 is appearing through all of these sets. So I will pick 1. Then next, you see that 2 is appearing through all of the sets. I will pick 2. 3 is here, 3 is here, but 3 is not here. That means that 3 is out. Let's look at this. 4, 4, 4. Then it means that 4, 2 is there. 6 is here, but 6 is not here. It means 6 is out. 12 is here, but 12 is not here. It means that it's out. So that means that I have 1, 2, 4 to be my common factors in all these three sets. To now find the HCF or the GCF of these numbers, you look through here and pick out the number that is bigger. So the greater number here is 4 because 4 is greater than 1 and 2. So I'll conclude by saying that HCF of 12, 20, and what? 36 is equal to 4. That is method 1. Method 2. Let's look at how the method 2 works. Method 2. Pick each of these numbers and put them into prime factorization form. So let's say I'll pick 12 first. Then now, you see that 2 is a prime number. So we can take 2 times 6 is 12. Then we'll take 6, 2 and break it down in prime form. So you see that 2 times 3 is also what? 6. So that means that 2 times 2 times 3 will give me 12. So in this place, I have 12 to look like 2 times 2 times 3. And this is the same thing as 2 to the power 2 because the 2, there are 2 here. Then times 3, which is the same thing as 12. Then I'll pick 22. So you see that 20, I'll have 2 times 10, which is 20. Then I'll break 10 into 2 times what? 5. So this simply means that 20 is the same thing as 2 times 2 times what? 5. And this will give me 2 to the power 2 times what? 5. That will give me 20. Then I'll take the other number, which is 36. Let me put it here. 36. You know, 36 will be 2 times 18. Breaking it again, it will be 2 times 9. Then breaking it, it will be 3 times 3. In that order. So that means that 36 from this will give me 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. And this will give me 2 to the power 2 times 3 to the power 2. So you look through all of this. Which of them is having a number that is appearing through? So you see that here is 2 to the power 2, 2 to the power 2, 2 to the power 2 is appearing throughout. So now, I can now say that my HCF of that numbers will be 2 to the power 2 and 2 to the power 2 is 4. So this is how we use the second method 2. Now, method 3. Method 3, take 12, 20, and 36 and divide them by a common number, a number that can divide all these numbers without a remainder. So you can see that all of these numbers can divide by 2. So what I'll do is that I'll take 12 over 2, I'll get what? 6. 20 over 2, I'll get 10. Then 36 over 2, I'll get 18. I will now pick 6, 10, and 18 and see which number can I use to divide through them without a remainder. You can see that 2 can divide again. So I will take 6 over 2, which is equal to 3, 10 over 2, which is equal to 5, and 18 over 2 is equal to what? 9. So at this point, you see that there's no number that can divide through by 3, 5, and 9 without a remainder. There's no common number that way. So you stop here. And now take the number that you used for the division and multiply them together. So you can see that the first division we use 2 throughout. Then the second division too, we use the same 2. So meaning my HCF will be equal to the number for the first division times the number for the second division, which is also 2. So 2 times 2 is equal to what? 4. It's like if the second division were using 3, then the answer would have been 2 times 3. But it's just that we are using the same 2 again to divide. So you see that that one too is given us 4 as our answer. So these are the 3 ways that you can use to find the highest common factor or the greatest common factor of numbers. And I've just used one example to explain this. I will record another video for this particular aspect using different numbers, and we'll use the same 3 methods again. For you to learn basic maths or advanced mathematics, just subscribe to my YouTube channel, Nabla Online Maths, so that you'll be notified anytime a new video is being uploaded, because I'll keep on giving you more methods, more tricks to learn your mathematics at home. Thank you for watching this video. Bye bye.